Background, okay.
Okay. Good morning, good afternoon, or good evening, everybody. So today, Rohit is presenting about large language model and its application in geospatial. So Rohit is a geospatial developer at Noxa. So this event is organized by Nepal Geomatics Engineering Society, NGES, and OSGeo Nepal. And in this event, we will try to show some of the large language models, open source and both commercial, something like ChatGPT and their application in geospatial field. So maybe Rohit can get better idea in this field, and then he will share us his experience and his knowledge. So it's up to you, Rohit. So yeah, take the mic and get the flow.
Okay, thank you, Tech, for the introduction. So, first of all, I'd like to thank NGES and OSGeo Nepal for giving this platform to share my experience about large language model and its geospatial applications. So, we'll be learning about like this new technology that it is booming. So, it has just started in 2017 with introduction of like that transformer model. After that, lots of advancement has been going on, and it has been in like entering in other industry also. So I think it's time to explore in our geospatial industry also. So I will be we'll be discussing about various use cases and some technicalities about large language model. So I'd like to share my screen first. Okay, my screen is visible here.
Yeah, see you.
Okay. So before starting, I just want everyone to like do a small survey. I just want to ask how many of you are using like any form of large language model, um, that may be ChatGPT, Gemini, or Cloud AI, right? So I think everyone here like had used such type of LLM once in their lifetime. So can you go into the menti.com and write something like how you are like using, for what you are using large language model for, for in your like daily use cases. So let's do some like one small survey. I request everyone. So I have changed the tab. Two response has already come here. To do research on new topic, to summarize the text. That's the like one of the like two of the use cases we can see here. So any other use case? Summarizing long document. Yeah. Utils while coding. Yeah, yeah, yeah. That's what I also use most of the time to generate utility function. I think you must be some software developer, like geospatial developer. We are not getting more response. Mm, let's wait for some second. Yeah, paraphrasing, getting general information on new topic. There's code assistance. Yeah, I'm also using GitHub Copilot, which is helping a lot to generate high quality code. Paraphrasing, that's also like nice use case. Okay, I think that's we can stop here the survey. I think like that I have used them all to figure out how good they work. Okay, just testing. Okay, okay, that's like we have seen like a couple of use cases that you guys have been like using different kind of LLM. So like this shows that you have already accepted this technology into your life. There are other use cases also, so we will discuss more in this presentation. Let's jump into the slides. So sorry, can, can you mute? Okay. Let's start with generative AI. Actually, artificial intelligence has been with us from long time, but classical statistical based AI, they used to create like ML model, which we used to know the output like predictive and like a predictive type of ML model we used to create like where we used to know the output already. But unlike that, in case of generative AI, we like AI model can generate new content, like learning the pattern from the training data, right? So in case of text, we have LLM, that is large language model, and in case of other space like in image space also, there are a couple of technology that are like going on, and they have also been able to create high quality images just using textual prompt. And if you have like seen that demo from OpenAI, they have like introduced like video generation technology also, that how like realistic video were generated by um, that model, Sura model. That was amazing. Technology are coming, and we are like experiencing this type of like thing in our life. I think before 5 years we were not like imagining this type of technology coming into our life. So it's like a revolution, and we are just starting. Lots of changes are still coming in the future. So that's about generative AI. And we have large language model. Actually, large language model is a type of advanced generative AI, like modeling. And what happens here is it can generate like human like text. It learns the pattern from uh, like textual data that are like the training data in this type of model are like from all the internet, from they have like they train the large language model uh, that from the text that are publicly available into the internet. That can be articles, that can be website, that can be anything that are publicly available, that can be documentation of something, right? So it's like we can consider that the training data is quite huge. We can consider that, right? So it can it can learn from the like sentence that already that people have already put into like in the public domain, and it can generate human like text. I think you already have experienced with the like this type of technology with chat gpt or cloud AI, right? So I don't think that I it needs more explanation. And we can see here like you may have like seen somewhere that this LLM is of this number of parameters. You can see here different types of like aspects are there for like question answering. there will be like a couple of million of parameters. For logical inferencing, there will be couple of million, right? So that's different aspects will be there, and there are various calculation going on in the LLM itself. So we are not going into their technicalities, but that's how like LLM works. Let's know some of the basic words, some of the basic terminology of LLM, which may be used in the coming slide. First of all, token. Actually, token are the like basic unit of text, right? Or the part of text or character. It's like a basic unit of LLM. So you can see in the example, if some sentence is there, I love cats, then I love and cats are like tokens, we can consider them token. But every like number of words and number of token may not be same. Sometimes like noun and like in case of like loving, love is one token and ing will be in another token. So that's the different, like that, like number of token and number of words may differ. So in case of LLM, there are a lot of calculation happens in under the hood. So yeah, using these tokens or using this character, their LLM cannot do a lot of calculations. So every token has to be represented as like as a number, like as a vector, right? So that's, we call it embedding, that helps LLM to understand the relationship between words. So every like it actually LLM works on the like calculating the relationship of words, what context, in what context it has like um, in on what context the people are asking the question for, that it understand everything doing the calculations. So if you like, if you want to know about context, context is like it considers the surrounding words, and that means it determines the meaning of ambiguous words. So here in this example, bat in baseball, bat is different from bat flying. So it has that capacity to differentiate such type of ambiguous word by itself, like parameter, like we have also discussed before also. Actually parameter are internal static that are existed during training. Actually we can take parameters, the more parameter it has, the better understanding of generation of complexity. It can understand more complex text, right? So that's the basics of LLM. So actually it started in 2017. That's the paper of attention architecture of I think every most of the LLM that we see are based on this architecture. There are a lot of people are from Google, and this is one important concept of attention mechanism, how it works. Like I like to make everyone understand using some example. So some people ask about tourist place of Kathmandu, then it break down all those sentence into like token, right, you can see here. So and it assign weight, which token has greater weight. In this case tourist places and Kathmandu have higher weight. Like it is determined by the what type of word is this, like it is noun or verb, or how common it is, like it is being used while training. So in such way, like weight is being like assigned, and there are a couple of words that are of lower weight, like off in this case. And it focuses on like higher weight keywords and calculating like doing some calculations, and it predicts next token. We can see what the answer here. Top tourist places in Kathmandu include Swambhunath. So what can happen is that Swambhunath, it knows that I want to extract tourist places of Kathmandu, and it may be taken from one source, like like this Swambhunath information may be taken from one article that has written about some tourism places of Nepal, or Bodhanath could be taken from another source. So it can know, we can take the information from different source and like give the output is like human readable format, and is of human would give, right? So the basic visualization I just want this is just two-dimensional visualization. One aspect here, we can see every word and sentence, like similar type of words and sentence stays in the same place, and uh, we can it can find the relation between other words also. So basically, it's in case of emotions showing, the couple of level are there. So it's in this example, happy birthday dude means joy, that like emotion is joy. And you can see here, curiosity is far from joy means it has some sort of relationship. So it has like LLM could have billions of parameters. This is just, you can consider this as one parameter. Like we can only visualize one parameter at one time, but similarly for other parameters also, they stay in the similar way. The similar words are like in one space, and different word are in different space. So the point is, every words and sentence have relation with other words and relation, sentence. That's how we can somehow visualize think that considering these things, it will predict the next token. That's how LLM works. That's the basics of LLM. Let's jump into the freely available LLMs and some of the open source LLM that we can try out now. So actually, ChatGPT is the one that showed us the power of LLM, what it can do. So most of the people may have introduced to this technology after the introduction of ChatGPT, I think. So it's powered by 3.5 GPT 3.5 model and GPT-4. We can get it for free, but GPT-4 is not free. GPT-4o is, we can, for limited version we can access it, and it has that capacity to search into the internet also. Like that, in the past we used not used we didn't have that, it did not have that capacity to get the updated information. It used to be give information from, I think, from 2022. That's After that we have Gemini, recently introduced. They have uh, done the revolution, like showing uh, creating the capability to take 2 million context window. That means we can insert whole book or couple of books in as an input, and we can ask question related to that thing. So that is also one of the revolution that recently Google has introduced. And we have another option, Claude.ai. uh, Claude AI. So that is also we can get access to. So different types of LLM gives different types of systems for different type of use cases. We can try out every every option for different use case, different outputs may be there, different quality of yeah. So in open source option, we have Meta is doing a lot of thing. So recently they have released Llama 3, which is quite powerful. Benchmarks are showing that it's powerful as GPT-4. But similarly, we have Mixtral AI, which is in open source from the beginning. So it has also 17 billion parameter model, recently introduced. And Gemma is from Google, which we can run it on our local machine also. 2 billion model, like that's the small variant. I'll be showcasing that model running into my machine itself later. So uh, now how I am using LLM daily, so actually, after the introduction of LLM in my life, the thing, couple of things has changed. So in the past, how I used to do searching thing, how I used to do research on some new topic that I have to do in my work. So I used to Google about that topic, and I used to go in couple of website, or some documentation. If I'm learning about framework, I would go to the documentation. So I had to go into different sources and I have to skim the specific data that I want to extract, right? So it was like time consuming process. So now what I do is I just ask LLM first, what do you know about this technology, or what do you know about these things? So that's one thing that it has changed in my life. And I specifically use one tool named Perplexity AI. So this is quite good tool. Like it can be like completely free, not completely free, but in some extent we can get it free. um, I want to do some research on DocDB. That's the new technology in our industry, right? So I just ask what DocDB is it from these sources it also gives the sources, and it summarize what I like it summarize about its capability. And I can continue asking question like what are the advantages of like using DocDB over other database system, right? So these are the the good thing is I can get the source like within itself, right? There are a couple of video suggestion also here. So two type of like searching I can do at the same time. So that's one thing that has changed. Another is actually I have been using GitHub Copilot as a coding assistant because it can give high quality code suggestion while I'm writing code. That's the same that I explained before, that I what I used to do to search about like new thing. So that is same for the, like while doing coding also. So we have that tendency to we if the task, like if the like technology or any task we is not repeated, then we have tendency to like forget things, right? So if I have to write something some code on Python that I have not been using for 6 months. I've been using for like before, but I'm not using for 6 months. Then I had to do some sort of uh, like research. I have to validate some like find if some specific package. Like if I'm using GeoPandas, then I have to like revise that thing, right? So what it is solving is it gives quite nice solution while I writing code. I can show you the demo here. I want to share the screen, sorry. Look, consider like I want to connect, like I have one database running in my local, so I want to connect that database into Python based environment. So I just will write connect Postgres database. I'm just verifying the code it gives. So that's the best thing. I don't know why it's not suggesting. You can see over here. DB name is wrong here. Like we should verify is it giving wrong. The thing I can continue from here. Like what like I can like verify if it's not right, then I need to like do some sort of modification. But the point is, it gives the high quality like code solution to me while I'm writing code. So I can I don't know why it's giving wrong answer right now. Or it's not giving right, correct answer. So okay, let's leave it. But the point is, for this specific use case, it was not like giving like code correctly, but it gives nice quality code while I'm like writing code, right? It also helps me to do debugging. So there may be there sometimes there may be like code that I have written, I have some bug into it. So it helps basically it is the LLM is LLM powered application is running in into my working environment, that is in VS Code. That's the that's what it's being so useful for me, right? So if I have to like go into some chat GPT interface and asking questions, that may be like tedious process. So it has been helping in such way. And another thing is, as a software developer, we don't like to write documentation and test cases. So it's also like LLM is also assisting us to write documentation and a lot of test cases, which prevent our application to break in like production, right? So let's learn something about like geospatial use cases. I think couple of LLM can do geocoding. So first, like one man has like done some like comparison between the geocoding response that are from LLM and some other service provider like Geominetim and Google Maps, right? It's saying that for some famous place it can like it can give correct geocoding like coordinates, but for like places like street it may not like be that accurate. So I think for to extract the coordinate of this place uh, we can just ask the coordinate in LLM itself. It has that capacity to give coordinate of famous places, right? So there is data collection. So basically mm, data collection is one step that is so crucial in our domain. So actually geospatial industry is whole based on data, right? So it is also helping us to collect data from LLM itself. So one example is we can just ask for the data. So you can see here one in this demo I have like asked find all hospital within 10 miles of Kathmandu. So it had given me this sort of like data, and it was not giving in sort like in our format, that is GeoJSON format. So I asked in GeoJSON format, and I visualized it in GeoJSON IO. Sorry. Yeah, you can see that like the data is giving was completely right. This is KMC hospital. This is Norvik, right? So we can just ask LLM that to give some sort of data. So if the data is in huge number, it may not give, but if the data is in very low number, it can like in it can like fit into that output token. Then that's okay to ask. That it can be useful for like some sort of um, like some sort of a prototyping thing, right? We like synthetic data generation, or we may not need to like prepare by ourselves for some demo project. So that so there that this can be quite useful for useful. So another thing is one great source of OS like geospatial data is OSM, right? We should thank OSM to collect all those data and keeping it free for everyone. But the one problem that we are facing is we can is extraction. It has data, but we have to that there are big number of data, and it has like different types of features. It has different types of query input. Like I think everyone here is using overpass turbo to extract OSM data, right? So I think we have been using this website to extract. Mhm. But when I come here, I don't have any idea that I forget the syntax. I don't know the keywords. What was it to extract the um, to extract buildings, or so to extract hospitals, to extract restaurants, right? So that was one problem that we that is still that the problem is existing. But what LLM can do is it can generate high quality OSM query by itself. So I have created one tool named OSM GPT, which is powered by GPT-3, and it helps you to extract different types of uh, OSM data, just asking like simple types of natural language in just simple natural language, right? So if you want to like download rest hospitals, okay, get hospitals, I can just ask get hospitals. we can see over here. And after it's generated by GPT-3. After that we have visualized it into the map. You can, there are other enhancing features, like we can change the color and other thing. But basic visual extraction and basic visualization can be done here. So this type of tool, this type of LLM based tool can be helpful uh, uh, like in such situation where the time is so crucial, like for example in disaster response period, right? There was a specific use case I just want to share here. So last time there was an earthquake in Jazakot, which last year I think. So at that time, like there was our team in our like office in Naksha, the DRR team was there doing rapid assessment thing. At that time, like data is quite crucial, and data extraction is also quite important. They need to extract all sort of data so quickly, right? So at that time, they use this tool to get the all type of data in Jazakot in just a couple of minutes, which could have taken them to extract, like they taken them 1 or more than 1 days to like extract all type of data which is needed to do rapid assessment, which has also impact on the like affected people in Jharkhand itself, right? So that's how this tool had been that useful. So I think LLM power application will be coming in the future. So that's about OSGPT. And data in case of data processing also it helps, like to convert unstructured data into structured data. Consider that you have some sort of data that are in textual form. So for this example I like to give one. This is the household data uh, from like some village named Danagav, right? So they have like the surveyor had gone to that village and extracted this type of data. But the problem is if we have to put it into the some sort of Postgres or a database, relational database, that will not work. You will have to like give time to convert it into some type of structure, right? So that's where LLM comes here. So I can show you the demo here. This type of data was converted in just within seconds. You can see here I have just written this command to convert it into the JSON format. And after that, it is in structure that could have taken that you could go into the sheet and see the text, what information is this, right? So there is one reference number. uh, you can see over here that will be using to for the data processing also, right? Data integration means there are two different source of data, and the other source is like another another bunch of like server have been collecting the GPS coordinate, right? So uh, we have to merge this like unstructured data to we have already converted to structured data. And these are the like sorry, I have put that JSON file into this, so I shouldn't have done that. So this is the data that imagine that some other people have collected. So we need to we need to combine those. We need to join these two data, so it can be also done by LLM very like easily. So it had combined both the thing like as a properties that the data with that was converted that JSON format, and another is geometry. Like we have like especially connected these properties with with this coordinate. Like everything is done by LLM. So sorry, this Chat GPT specifically talking, right? So that's how it has been like useful for data integration also. Another thing is it is based in like generating spatial query also. So imagine this is the data that are um, in geosession format, but I need to insert into some sort of like database. Then I think it can create query by itself. It had like create the schema you can see over here, just simple prompt you can see. So I like to run this into my database. Sorry, not this one. So this is page element connected to my local database. You can see over there the database has already um, connected. Mm, I have already enabled the PostGIS extension. You can see over there. Let's run that script uh, here. Let's first make the table. That's the table suggested by ChatGPT. Okay, it was successfully executed. Let's see if it had, like, yeah, we can see over here family table had already been created. It's all like it's all done by like LLM, right? I'm not doing anything. I'm just writing. I'm just asking in this textual format. So to insert, I just want this command to execute. Like I think we have that. Um, with the data already inserted, you can see over here how we are able to like get the data into our database too quickly, the unstructured data to structure, and we combined with the GPS coordinate also, and we have already like imported all data in our database itself, right? So that's amazing, right? So that if I have to do this by myself, then that would have like taken a lot of time. Here also it saved my time, right? So okay, let's do some sort of GIS analysis also. I think I'll show one demo just by like just by creating buffer uh, from the code created by ChatGPT itself. Okay, uh, these two, let's execute this code. Let's copy this. I'm just copying. Successfully executed, and I want to probably like we can check into the data. We can see over here the buffer had already, there is one another field like buffer geometry, right? So it had already, we can visualize it. It had created like buffer and stored in one column. That's the amazing thing. I have not written any code by myself. It's just giving like from the GPT itself, right? So that's the amazing thing that it had like it's saving our time basically. It's saving our time, giving like some sort of coding, like code suggestion. Uh, what I can what I'm trying to say here is um, it it has not directly helped with help by doing some sort of problem solving by itself, but it's assisting us to giving some sort of code like that already we know, and is like saving our time. That's the like that's the summary of like some of the use cases that we have been using. So there's one paper I like to show you what they are doing with artificial sorry LLM is that they are trying to uh, that like this paper shows that they are trying to automate everything. They just give some sort of like question, and everything will be handled by LLM itself. They are like saying that they are self-generating, self-organizing, self-verifying, self-executing, and self-growing. So everything is done by LLM. Just we are like we will be there to verify whether it's like whether it's giving right suggestion or right, no, or not, right? So you can see over here, first of all it uh, creates that one graph, what sort of tasks it's going to execute. So it divide different types of operations, and it's like you can see over, like see the label here. So for like intermediate data is data, intermediate data is yellow color, and the input is green, operations blue, and financial is pink type, right? So this graph shows that what tasks it will going to execute. And we can see next, we have like some all sort of operations. It will generate code, what are the operation needed, and it will after that it will assemble it here, and it will give the answer here. Like if we would like there's one example I'd like to show you. Mm, the question is, you can see the question is about to find the like um, population that lives within the census tract that contain hazardous waste facility, right? There are two questions you can swear to generate the map with like highlighted border, right? So for this type of question they have like also given the like link to the data set, and it had like created that workflow what it will going to like um, going to execute. You can see over here. So there are two types of like three in point it has started to do operations. This is the data source you can consider here. So for the operation is blue is loaded, and is geo data frame is like made here. And you can see for like population data it's data frame is made, and combining this joining these two table, um, track population had been there. And you can see here from here it go into like two direction you can show here. And for two different tasks it is generating the population, and it's total so it's generating population map with red highlighted. Is everything here was generated by every operations that we can see over here was generated by LLM itself. So that was one best use case I can see. This is just a proof of concept, this is just the beginning. I think they say that they have powered on GPT-4, which is quite expensive, we cannot afford it. So but what we can do sort of fine tuning and other stuff in the in the future. Okay, that's one amazing project that I have seen. uh, but large language have their own limitation, right? The one limitation is they are trained on everything, they know that they have surface knowledge on everything, but they don't have that uh, knowledge on some specific domain. In case of like in our geospatial case also, we don't have that I don't see any type of geospatial based foundation model that are still like missing. So what we can do, we can fine tune, like we can fine tune some foundation model that have that knowledge, understanding of language, and that can process like some that can understand some sort of language, and we are adding more data, geospatial based data into it, right? And that's the fine tuning. And another technique is retrieval augmented generation, that's RAG. I'll explain this like in the later part. And there is function calling. Let's go into the like fine tuning part. So you can see like how fine tuning works is like there are already pre-trained model, uh, like uh, like we can take some open source model like Gemma, which is like 2 billion parameters. We don't need other we don't need knowledge of other domain, right? So we can it's like a domain adaptation. uh, we are like giving more data into it and labeled, and it will be able to do tasks that are specific to our domain. So that or we can we can call it like instruction. We like pre-train model are foundation model are on level, we can take in that way also. But after while doing fine tuning, we label data is inserted into it and we do some sort of fine tuning, right? So that's what fine tuning is. And we have a RAG model. So I have mentioned before that every word and sentence are like represented in number. So we have uh, vector database that stores the numeric representation of words. And what we can do, we can while querying, if some more information is needed from vector database, it knows from here, from doing similarity search and semantic search. Then like the text that is more related to this query will be extracted from vector database, and it makes the query more powerful. It gives it to the LLM, and it like we get the response with like extended version of prompting, right? So that's how like RAG model works. I like to show one example how it had been quite useful for us. uh, so, where was that? So while working in like big like production level application, we write a lot of utility function, right? But what happens is we do that the new person comes into that project as a developer. So it's difficult to find if something is had already written or not. So I have created one like tool which what it does is it takes the for this specific use case is taking this file functions like Python based function is just synthetic function that I have prepared for the demo only. So what I can do, I can do similarity search. So I can jump into that exact project, sorry, exact function that um, I want to go into, right? Util search. So if I type util search, so it's generating the embedding of these functions from this, taking this description, right? So I can now ask if there is any function that can calculate the bbox. I'm not asking that exact word, but similar to that word it can do similarity search. For example, I can like ask uh, is there any function um, that create bbox. I'm using bbox keyword instead of bounding box. Bbox from poly only. Instead of poly, I'm just writing polygon, right? So instead of polygon, I'm writing poly. So if I enter into this, then it had like find that information from that like vector database. That's, it knows that I want to get the information like this text is similar to the query, right? So what it has done, and I can just like as an extended feature, I have like put this feature, and if I put as, then I can jump into that same project, same file, and uh, the exact line number. So that's how the RAG model has been using, it has been useful for us. So it will be extended to know every every code base that we write is just working in the Python function. We are trying to expand this um, to get the query that what are like how code has been returning like written in the past, just doing this query. Just one example that RAG model has been like quite useful. And I can what I that till now what I only am searching for this specific use case. But what it can be done, we can I can ask more question like with this context, like modify this information. um, this function like I think we can modify uh, giving more prompt like change this function to this, like change the constant to some sort of other things, right? it will give that it will update that function, and it will give me that newly generated function to me, which can be quite useful. I think. Let's know about function calling. Function calling, there's another limitation of large language model, that it don't have that information, it don't have like real time information, right? So if I ask the temperature of today, then it will not give me the answer, because it is a snapshot of the data at one point of time, right? So at that time it didn't know about the temperature of now, right? So what can we do, we can like pass the function, we can pass the definition of a function to the LLM, and it will uh, it will make us realize that it's time to call function, and we can do API calling from some source that gives us temperature data. Then we can combine that information again into the LLM to make to give like real time information into it, right? So that was one problem that this calling solves. Another is there is the concept of AI agent. That's a hot topic. So we have been like using LLM in the um, user interface, like in ChatGPT or some other like Gemini or some Cloudy, right? But it can be used, we can use it to create agents that needs less computing power, and we it has that capacity to call any execute the code, and it has that capacity to retrieve the useful information from any other document, and or it can communicate with any other types of LLM or other type of AI agent itself. So it if you give it that power, if you give that power, then that can be amazing things to have. Like there are like we cannot get real time information in like ChatGPT, right? So if you can achieve this type of thing in our life, then that LLM can be more powerful, and we can do a lot of automation things by ourselves, right? I want to show one demo which is not geospatial based, but still you can see over here there are a couple of agent with these different types of tool. For this is like one example where couple of input are taken from user, and using some couple of other tool, it gets uh, like it can get the information from the internet, and it can summarize it, and there will be another agent. This is city selection agent. It will select the city that where we want to like go, and another agent is like local expert, it will explore more about that city, and another agent is like final itinerary provider that will prepare that structure itinerary for us, right? So what I need to is Python 3 from to submit. So it's asking for like human intervention is there. So it's asking for where trying from. I'm just writing India to Nepal, Kathmandu. I need to write Kathmandu. I think I'll travel from 1st June 2024 to 7th June 2024. What are the hobbies? It can be traveling. It can be like mountains. Now it started to work, right? So first this AI agent will work to get the information about where I want to like go, and local expert will be there. We are providing some back some goal here, and backstory here about this agent. So taking all those inputs, they can process and work like collaboratively. They are called like we the package is called Crew AI. So that's how things are working. So you can see they are working on their own, and at last they will provide me with the itinerary. You can see over here. I have like already drawn it, so I'll show the output. So that's the laptop is not as laggy. You can show over there like the agent work by themselves, and he had that he had internet access and couple of like calculator tool also. So using those tools, they have like come up with this itinerary. So similar to this, in our geospatial domain also, what we can do, we can like create, like we can take some sort of like a small language model that has the understanding of all type of language. And mm what we can do, we can train with some more geospatial data, and it can we can make it more into that like breaking down the task that are more specific to geospatial related works, right? So and we can give we can make it more updated using this technique, using RAG, using fine tuning and function calling. If it can access the that already written code, and you can it can execute by itself, then that can be a like good thing to have in our industry also, right? For example, let's assume that this is geospatial analyst, sorry, GIS analyst agent, which can break down task, like if some sort of analysis work comes from the prompt, like that similar to that example that we have seen from that paper like previously. And it can communicate with another model which has that capacity to process every type of PostGIS like query, like every type of operation in PostGIS. Or there is another model which can process every data in uh, like DocDB and Parquet form, right? So if they can communicate with each other, then like most of the things can be automated in the future. So I think that's one trending topic that's going on, like people are exploring on AI agent thing. I think we should also need to explore on that. So another thing that may be changing due to LLM is the map interaction, that the way we interact, we are interacting with map uh, is like in map interaction that we have like two things. What I think is, one is filtering of the data, and another is visualization, right? So if you can like talk to the system that what exact information that we want to extract, then why do we need to put this sort of noisy like UI, right? So we can just ask this information, I want to filter this information. If there are chunks of data that are like already rendered and you want to do filtering, right now we are like doing like checkboxing, like there used to be like checkbox, and we like do um, like we control with the UI element, right? But the problem is let's make it more noisy. And with the introduction of this type of technology, what we can do, we can just ask our system what information that you can provide to me. It can like analyze, it can analyze what type of filtering it can do. Is it can like for example, it can generate SQL query, right? So it may not like SQL query may not be used. We may use like some sort of Python based like code generation also. But the thing is, we can just have one like chatbot here, and every visualization would be there uh, in the future. So that that's my prediction that may be coming in the future. So that one demo I'd like to show you. Not a tab are opening. Let's close it all. You can see over here how clean it is. Just asking. So if you like, we can also ask what are its capability, what are the capability of your portal. So we can, if you are like asking that that's not possible in this portal, then it can be given by the like chatbot itself, right? So you can see here it will like highlight, it will highlight some of the field, like some, like you can see over there it had asked for bathrooms, right? It has highlighted the bathroom only, right? So another, like it will do filtering around now. Yeah. It had asked like where is the largest bathroom, then it will process the data in the backend, and it can like get the exact like item that we are looking for, right? So that in that way, I think the way we interact with map will also be changing in future. So we have like useful tools here. So I like to show one like demo that how we can run open source model in our local machine. So this is the tool that helps us to download open source large language model into our machine itself, right? So these are the model, and you can see over there what are the available models that we can download. There are a lot of open source model that we can download, right? So I can access it into the terminal itself. mm, llama run llama list. I've already installed. After installing, you have that access to these tools. You can see over here. Uh, these are these are the models that I've already downloaded. I can check one Gemma 2 billion model. The problem with this model also, like we don't have that like high end machine. We this big model, like even 7 billion model is not that effectively run into my machine. So only 2 billion model can run into this M1 year with 8 GB RAM. So I'm running it. So that is completely offline. So if someone are concerned about like that data privacy, right? So they can use this type of models to use, but the problem is they are not that powerful. They cannot generate exact like thing that we are asking for. They cannot generate geospatial based query and Python like GeoPandas code, right? I can I like what do you know about OSM? Let's ask about OSM. Yeah, it's running in my local machine. It's quite fast, right? But in case of other like 7 8 billion, more than 8 billion, I cannot run it. It will hang my computer. So I think it's taking a lot of memory also. Like, memory is not being used. There are a lot of information it's giving. So another use case I can see over here. It's hanging my computer. Okay, it's done. We can use that power of RAG model here with open UI, which is running in my local machine uh, in 3000 port. So its backend is Olama. You can consider this as the front end, like client side thing. So it's powered by Olama, and we can choose the Olama model from here. So in setting, we have to give the the URL that's running, that's localhost, don't confuse with it. uh, if you see that the Olama is serving open source model in one endpoint as API, right? Olama is running means this Olama and this UI is communicating. We can see this chat interface is similar to ChatGPT, and we can what one more use case you can see over here. I can give the PDF here, and I can chat with this PDF here in my local machine. So this can be used for like to extract some sort of to document that are like quite crucial for you, right? So that sort of document can be uploaded in our local machine, and just ask summarize it, summarize it. Model is not selected. I have to select Gmail model, so I can ask. So it's all running in localhost, right? You can see over here, and it's running in localhost. So it's taking a lot of time. I don't know why. So I'm sorry, it's taking. Sorry. So I'm not able to generate sorry the context. I think my memory is out of. I'm here. Oh, can you see me, guys? Am I disconnected?
No, no, no. We can hear you and see you well.
Okay. So like I think too much processes has been like using this type of model. So sorry for that. So but what we can do with this tool, we can just upload the like secret PDF here, and you can ask into it. You can ask for summarization. You can question it and get the answer from the PDF itself, right? So that can be done here. And and another is Hugging Face. We can if you want to explore more about what are the models coming, new models coming, and what are people doing in this like model creation space, then you can go into the Hugging Face. You can explore various model are available here. Every model, like you can see 22,000 pages are there. So every open source model is like a repository for every open source model. It also hosts your open, if you are able to fine tune some sort of model here, then you'll have that chance to upload it here and make it public. Everyone can, so that everyone can access it. So different types of model are there. So I have seen one interesting model that uh, I can see. So sorry for that, I forget that model, I cannot find it. uh, and another tool is LangChain, which is if you want to, like if you are a software developer, you want to create some LLM based application, then this you have to, like you need to learn it, and you can it what it's dodge it. So it's like a framework uh, with all type of LLM based reusable codes already they have like created. And you can see over we had discussed about drag model, other technique, right? So they have already defined, and they they have like that collection of different functions and things that we can use to make production level LLM applications. So that that's what like Langchain can help you. And there is extra as a bonus, we have True AI. If you like want to dive into the like agent thing. So if you are interested in like how agent works, then Crew AI can be one option to like learn. So that's the tool. And as a conclusion, I want to conclude this session like saying that LLM can be used to boost the productivity, saving time. Like it's not like, and right now we are in that stage that it's not solving whole problem, but the uh, it's saving our time by assisting us, right? So uh, in different way we have been like using these things, and which saves time, either by giving code suggestion, or either by generating some geospatial based like operations code, right? So it's saving our time. And still there are other a lot of advancement are going on to this like generative AI space, but we don't see that much advancement in our geospatial like domain. We cannot see any type of foundation model till now. So I think in future there will be more foundation model coming, uh, and there will be more LLM powered application in the futures that will enhance our workflow. uh, mm, that can be like one tool that helps us to things get the things done very quickly. And that's it. Thank you.
Thank you very much, Rohit, for this wonderful presentation. Yeah, your presentation is awesome. I really enjoyed the presentation and all the content. It's very like lots of knowledge from them, and yeah, all things are going up my head. But anyway, yeah, it was an awesome presentation. And yeah, so thank you very much. Now we will move to the question and answer session. So I see lots of question in the chat from Chitis,
Uh-huh.
and we can take the other questions as well. So if you have question, feel free to put it in chat, or just unmute yourself, then ask a question. But first of all, let me take one question from chat. So the question is about, you mentioned you mentioned you use Copilot and Complexity AI. How
Mm.
GitHub Copilot and Complexity AI is?
So sorry, so I cannot like I cannot hear you.
Okay.
So it's
Uh, is my voice clear now?
Take your microphone is like super noisy. We can
Oh,
barely understand.
yeah.
Hello.
Yeah, it's now clear now.
okay. So the question is, you mentioned you use Copilot and GitHub Copilot and Complexity AI. How ethical GitHub
Perplexity.
Copilot and Complexity AI is?
It's perplexity, yeah, I think. So yeah, like we don't know that how they are taking our data, and either they are like, training on our own data. But why the reason of me using those tools is like it is creating like value in my like daily activity. So I'm using it. So I'm still unaware of that what they do to my data. So perplexity is, I think they are not doing anything. But in case of GitHub Copilot, I think they are training on my code itself. So for like data privacy, I not getting that much. So I'm using.
Yeah. Anyway, thank you for the answer. Okay.
Mm,
There is another question from Chitish. I really like this question. The
mm.
basically the second part, but let me read the question for you. What's
Yes.
the tool you have used in Visual Studio Code Editor? And another part is, do you think LLM can kill creativity and make us dependent?
Uh, What tool I am using? Yes, that's GitHub Copilot. I think that's like same question. Asked to your question. That's the GitHub Copilot that I have been using like to assist me. I think where is the question located here?
And the part is, do you think LLM can kill creativity and make us dependent?
Yeah, I think so. So the like we should not be using in the initial part. Like if we have like if you have that foundation like already, like if you are not skipping the basic concepts, then we are doing like repetitive type of thing. Like I can write code in like Geospatial that I can write by myself, but it is assisting me. That's the problem. But like if you are using it in the for the basics, then it may kill like creativity. Like that's so you should not be using in the beginning. So I suggest everyone for that.
Okay, yeah, thank you for the answer. But I think nowadays everybody use LLM, and even they don't heard about Tom, they just try to write the code because it's
Mm-hmm.
very right. So yeah. Anyway, yeah, I also feel like it's killing creativity, but don't know. Yeah. Okay, let me take the other question. How
But
can
like, if we are not using like these things, then other people will use it and boost their productivity and will fall behind. That's the risk of that thing also.
Yeah, that's a great answer. Yeah, yeah, I
Mm.
like the answer. Okay, let's move to the other question. How can we trust LLM available in the market based on your experience? Do open source LLM has capability to provide source and logical reason behind their answer?
Yeah, in case of open source model, they are not that much powerful as like other options like OpenAI, like ChatGPT, GPT of OpenAI, and like Gemini. But they are like growing, still growing. But what I see with open source model is we can do fine tuning things. So, for example, I'm using GPT for that, like that OSM GPT, right? So, if you can collect that OSM query of around the world and we can train it, then that will be like OSM extractor type of like model, right? That will be best model that other model can also use, like other people also use to extend that its capability to other type of works, right? So that's I don't think like open source model are that powerful is like other proprietary option. But if it is the case that we can like train it on our use case, then open source model can be a good option because it can run into our like low end machine also, right? So in that way, like open source will have to like we have to explore open source more still.
Okay, yeah, thank you for your answer. And there is another question by Chitish. I think he asked all the question that I was curious for. So thank you Chitish, for asking these questions. So another question is there a straightforward way to fine tune open source LLM? Let's say I want to fine tune LLM for automation, couple of API requests. How big I might need data for fine tune, and also wondering if personal personal average 1500 to $1000 laptop would be enough for this.
Yeah. In case of fine tuning, it will not cost as much as like it costs to create some foundation model. I think I have heard somewhere like to train Llama 3, it costs more than $500,000. That's a lot, right? We can afford that. So what we can do fine tune. But fine tune is like a super. We can like prepare some sort of supervised data, textual data, uh, that we can do. I haven't explored like fine tuning in my machine, but we can use Google Colab and other options. In Google Colab, I'm sure that it can like we can sort of like fine tune um, some sort of like small based like some specific more specific type of like fine tuning can be done in. like in Google Colab. But in case of like in our machine, it it's not good idea to train in our like own machine.
Okay, so you mentioned just like additional question on that question. So
Mm.
you said that we can use uh, Google Colab for fine tuning
Mm.
those more. Are
Mm.
you about like uh, freely available version or the paid version?
Yeah, yeah, really available version will train itself slowly, but if you can like purchase like $10 or something, we can like get more GPU and it can be trained like quickly also.
Oh wow, that's really impressive. Yeah, I never thought like it can be trainable in Google Colab, and
Cool.
it has only a 12, 12 GB RAM, right? Freely available, so that's impressive.
Uh,
Okay, so
if you have
let's
more time, it takes time. That's the thing. If you have more data, it will take time.
okay, yeah, yeah. Okay, let's move to the other question. So it's very long. Let me read it for you. You mentioned LLM can be used in disaster since accuracy of the data is super important in case of disaster, right? Let's say I
Uh,
ask how many hospitals are there in Jazarkot during earthquake response, and it says zero, even though there are. How would we validate that information? Won't increase more work? Do you provide the confident and source of data when LLM make prediction?
yeah, that's the nice question. So um, it's difficult to answer also because I don't want that like that model, right? It may sometimes give like wrong answer also, so we have to make sure that. So that's the one reason that I have put manual mode in the SMGPT also. So if you have like you are like expertise in that domain, then you can verify that output that LLM has given, right? So I don't think like we should like believe in sort of LLM right now. We should do some sort of validation also. We can like believing into it. So, so what can it can do? We may not do everything from scratch. So to get started, it can help, and we can modify that result from LLM and like, further proceed into that work that we are working on. So that's that I want to like say to Chitij.
Yeah, and there is few additional question as well. So, do you think it's a important issue, and is there a way to mitigate? For me, it's been the biggest challenge about LLM, what to believe and what not. If I'm wasting more time doing validation, then it doesn't enhance my speed. I would have simply went to this itself and gather it.
Yeah, 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 yeah. In some cases, it may like validation may take more time. So I think we should like, know that sort of task, and we should avoid doing those sort of tasks. So before like using it in like some crucial tasks, we need to like try it, test it. What are the like its capacity, and in which cases it can like be more useful, and we need less validation. Those sort of things should be used in case of LLM, I think.
Okay, thank you. I hope that answered the Chiti's question. Okay, there is I think final question from Chitis. I hope
Uh,
there are more from Chitis. Let's see. Okay, the question is LangChain open source or free?
yeah, 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 it's completely open source.
Wow,
It's completely
wow, that's great. Yeah. Uh, Yeah, there are not other question in the chat. So if you have question, feel to raise your hand and then ask it to Rohit, or just drop your question in the chat box. So I'll ask them.
okay. It's okay, Chitish.
Okay, maybe I have a final question, if no one has other questions. So my question is, I know you might have tried lots of like model fine-tuning thing already, but I feel like there are thousands of model, right? And then I might get lost into the LLM space, and it's it's too much foggy for me. So, what is the like best way to select which model might be a good for my use case? Do you have like, for example, any website which talk about like all the models and their capabilities? Uh, have you tried
Mm.
fine tuning any models?
Till now, I have not like fine tuned, but we are planning like cities, and we were planning to do like that way some query fine tuning thing in the past, but we did not have time to like fine tune right now. So if we have like some time in the future, we will try it obviously. But the question you are asking is that what how I can like choose the like best foundation model, right?
Yeah.
So in Hugging Face, you can just um, see its benchmark, and you can see how many people have downloaded it. That sort of statistic you can check over there. And and one problem is like if we are fine tuning, there are no foundation model in our space. So uh, you can choose that model that knows just language, that like, they have understanding of language, and that has understanding of every domain in the software with lower parameter like 2 million parameters, right? So we don't need any sort of other information about stock analytics in our use case. So I think like in geospatial use case, we don't have that much foundation model, so you can choose any. But personally, I think Gemma model can be a good option to choose because it's million more parameter, and it can be also run in my machine. So giving a lot of a bit of more data and fine tuning it. If I can run it in my local machine, that's the good idea, right? So if you have like 8 GB or more 8 GB, then you should not go for like model that have like more than 7 billion parameter, right? So that sort of things we should be considering while choosing.
Okay, yeah, thank you very much. So there is one more question in the chat box. So, uh, is there any documentation reference we could use to getting start to develop our own LLM?
Not exact documentation, but you can start with like Langchain. So Langchain had solved a lot of problems like tooling also. They have also entered in the space of agent also, right? So Langchain can be a good option. So if you are like if you are into like making LLM powered applications.
Okay, yeah, that's all about question, I think. Yeah. Uh,
Olama actually, I'd like to like make this clear that actually Olama is just just a tool that download open source model into our system, and it is like it gives an API interface from where we can like connect that from like other application also, right? So Olama is we don't need to do some sort of more research in Olama, just tool which will serve your like commercial model in your local machine. That's what Olama do. But in LangChain, you have to like know like the framework itself, so how it works, how like they have prepared like function like reusable function, that sort of things.
yeah. Okay, then I think we have you have answered lots of questions. So yeah, now it's time to like close this event. So thank you very much for joining this event. If possible, please open your camera. We'll take one photo and then we can end this meeting. So
Hello, Chitish.
I came to light just for this. Otherwise, I was like this.
Okay, any more faces?
Thank you, Gorak. Welcome.
Okay,
Thank you,
thank
Roshan.
you.
Bye.
Bye bye. Have a good
Bye.
night. Bye. Thank you very much.
Bye.